Hello, I'm Dr. Jeff Linick, and today we're going to take a look at complex numbers. This will be the first part of a two-part series where we discuss different aspects and concepts associated with the complex number system. Okay, so what we want to do is we're going to look at a couple different things. The first thing in this program, we're going to define the imaginary unit. We're also going to define the complex numbers themselves. We're going to examine the addition and subtraction of complex numbers. The first thing we want to ask is, why do we need an imaginary unit? Well, the answer to this is that in many algebraic problems, we are faced with a solution where there is a negative sign within a radical. And so we're looking at this and say, well, what does that really mean to us? Well, let's look back at a quadratic problem similar to that you might have seen before. And this is a problem we are asked to find x in the equation 2x squared minus x plus 3 is equal to 0. Now here, notice I've already outlined for us how to solve this problem, and the fact that we start out with the quadratic formula. And since this problem is not factorable, we can use the quadratic formula, or you can just pop right to the quadratic formula to see what the solution would be automatically. So again, in solving the quadratic formula, we need to recognize what a, b, and c are. In this particular case, a is going to be equal to 2, b is going to be equal to -1, and c is equal to 3. And so we basically substitute those values in. We can see that a is in the denominator of the formula and also up in the numerator of the formula. And so we can see that in the formula we're plugging in -1 for b in 2 places there. We're plugging in 2 for a in 2 places within the formula. And then finally, c being equal to 3 gets plugged into the formula as well. And so when we simplify this, we end up with x equal to 1 plus or minus the square root of 1 minus 24, all divided by 4. We simplify underneath the radical further, and so we find out that we end up with 1 plus or minus the square root of -23 divided by 4. Well, the thing that jumps out of us here is that we have the square root of a -23. And up to this point in your algebraic studies, you would have said that, hey, this is not a real number, so there's no solution. Well, we want to go beyond that. And so here what's going to happen is, as we look at this, we end up having something that's not a real number, and so we have to define an imaginary unit, or we can define an imaginary unit to take care of the problem when we have a negative underneath the radical. And so that's exactly what we're going to do. We're going to look at the definition of the imaginary unit. So therefore, to overcome the problems we are faced when there is a negative sign within a radical, we'll define the imaginary unit as I is equal to the square root of -1. Again, here we're using the letter I to represent the imaginary unit. And again, that's the connection that you can make. You can look and say, all right, imaginary I, and that makes sense to most people. It's kind of a nice practical thing in mathematics that we can use as we move along. All right, so let's take a look and see how we can use this idea of an imaginary unit a little bit further. So the first thing we want to look at is the powers of the imaginary unit. And here, the powers of the imaginary unit, I'm going to list them all out, and we'll go through them each step at a time. The first standard power, and these are really the standard first 4 powers of the imaginary unit, is the definition of I, and that was that I was equal to the square root of -1. Next, as we look, we see I squared. So the way we're going to handle I squared is, notice that we put the square root of -1 in parentheses, because that's our definition of I. We square it, and this comes out to be equal to -1. Now remember, what's going on here is that in our radical notation, we're going to see that there's an index there of 2. So effectively what happens, the index of 2 and the power of 2 cancel each other out to leave us with a -1. So the negative stays in this particular equation as we solve for I squared. Okay, moving along, we see that I cubed is going to come out to be equal to -I. Well, we take a look at the intermediate steps here, and we see that we can write I cubed as I squared plus I. So what we've just done is, remember, the sum of the exponents idea is used here. So 2 plus 1 would give us 3, because on the I there's an exponent of 1 there. All right, so we can break down I cubed into I squared times I. Well, we already saw just a moment ago from above that the definition of I squared was -1, so we bring that down. And again, I is our basic definition of the imaginary unit. And so we end up with I cubed being equal to -1, negative I, excuse me, negative I there. As we move along, we're going to take a look and see that I to the 4th power, well, again, what we're doing here is notice that I'm rewriting it in terms of I squared. And so I use the power to the power rules that we've seen before algebraically. And so I'm writing I squared squared. Well, we know inside the parentheses that I squared is equal to -1. And then we're squaring that. Well, squaring a -1 times -1 gives us a +1. So we end up with I to the 4th power being equal to +1. And so that's an important pattern that we're going to see over and over again. As you deal with the exponential forms of I, you're going to see that there's this sequence of, or a series of 4 powers that we use over and over again to simplify any type of exponential expression that contains I. So let's see one and see how we can actually use these 4. All right, so here again, I've listed the standard 4 powers to start out with up here, that I is equal to the square root of -1, I squared being equal to -1, I cubed being equal to -I, and I to the 4th power being equal to 1. So the problem we want to face is, let's find I to the 7th power. Well, we're going to proceed like we did just a moment ago. We're going to rewrite I to the 7th power as I to the 7th power is equal to I cubed times I to the 4th. Again, remember that 3 plus 4 is equal to 7. So if we go backwards in this equation, that's a lot of times you're used to doing that. And so we could go either way in this equation to either expand the exponential or simplify. All right, now why did I pick I cubed and I to the 4th? Well, this goes back to what we have up here in our standard powers. I have a definition of I cubed and I have a definition of I to the 4th. And so those both had the largest power on them. And so that's why I picked the cubed and the 4th. Some people might say, well, why didn't you pick I squared and I to the 5th? Well, again, I to the 5th isn't in this list of the standard 4. So what I'm doing is I'm going back to my list of my standard 4 basic powers of I here. All right, so let's proceed here and see how we evaluate this. Well, again, what happens is we pull down and we know that I to the 3rd power is equal to -I. We know I to the 4th is equal to 1. And so we get -I times 1. And that should come out to be equal to here as I. So I'm going to make an adjustment there in my little screen there. And so we see that we get the negative I as the answer here. So I to the 7th power comes out to be equal to -I. Okay, so these standard 4 can be used over and over again as you look at simplifying imaginary units that have powers other than 1, 2, 3, or 4, and you can proceed the same way. All right, next what we want to do is we want to take a look at expanding on the idea of, well, how is this imaginary unit used? Well, this imaginary unit is used in the definition of a complex number. Complex numbers are of the form a plus bi, where a is known as the real part and the bi is known as the imaginary part. Okay, so as we go along, we're going to see that we're going to be writing complex numbers in this a plus bi form. Once again, let me repeat that a is the real part and the bi is known as the imaginary part because, again, it has b with I in it. So let's look at an example here. If we look at 8 plus 5i, what we're going to notice here is that the 8 is our real part. Okay, so we have a real number there. It doesn't have an I associated with it, so our 8 is known as the real part there. As we look here as well, we're going to see that the 5i then is going to be known as our imaginary part of this complex number. And again, we saw an example previous with when we did the quadratic formula, and we ended up with a square root of -23. In just a moment, we'll return to that particular example and see how it works with this definition of complex numbers. Okay, so let's work a little bit more with this definition of complex numbers. And the complex numbers, this definition of a plus bi, a complex number in standard form if it is written as a plus bi. So you will see this as you work through problems. Many textbooks have this where in their section on the examples that you're working, they refer to things and they will say, place your answer in standard form with reference to complex numbers. And so our standard form is the a plus bi form. So just keep that in mind as we work along. Okay, so let's look at some other examples. And so what happens is we want to write in standard form 3 squared plus the square root of -1. And so to do so, the first thing we're going to do is we're going to simplify the real part here. So I've noticed that I have a 3 squared here. So that's 3 squared becomes 9. Again, 3 squared is 9. And so I just rewrite that as 3 squared plus the square root of -1 is equal to 9 plus the square root of -1. Second, I'm going to simplify the imaginary part. So the imaginary part here is the square root of -1. And again, I've continued on the problem to show you the complete solution from 3 squared plus the square root of -1 is equal to 9 plus the square root of -1. And so now I'm going to take that square root of -1 and I'm going to convert it into my imaginary form by the definition of an imaginary number of I is equal to the square root of -1. And so therefore I end up with 9 plus I. So I can say here that 3 squared plus the square root of -1 is equal to 9 plus I. And again, we've got that standard form of a plus bi here. So a plus bi, in this particular case, your I, the b in this particular case rather, is going to be +1. And again, that's a given just like we would in any algebraic expression. If we had x, it would be 1x. Okay, so that's an example of writing a complex number in standard form and doing some simplifications with it as well. Let's take a look at another example and see how this also might work in different situations. So we've got the scenario here where we have 3 minus 2 in parentheses squared minus the square root of -4. Now notice in this one we don't just have -1 underneath the radical, so we're going to have to do a little bit more manipulations here, and so that's what we'd like to show you here today. We're going to first simplify the real part. Again, notice I've got a standard approach to this. I like to take a look and say, let's do the real part first and then we'll deal with the imaginary part. So basically what happens is we see that if we have 3 minus 2, we know that's going to give us 1. So 1 squared then is just 1. So we'll pull that over here to the other side. And so we'll have 3 minus 2 quantity squared minus the square root of -4 is equal to 1 minus the square root of -4. Now, word of caution here. We've got to be careful and make sure that we bring those proper negatives forward as we just did. And so next we're going to separate the radical out because we're going to notice that this radical here is just not -1 underneath the radical. So what I'm going to do is I'm going to rewrite this. I'm going to take this previous step that I had up here of 1 minus the square root of -4. I'm going to bring it over. I'm going to separate the radical. Now, what do I mean by that? So I take the square root of -4 and rewrite it as the square root of 4 times the square root of -1. Now notice I do keep that negative sign in front of this. Okay, so that's important. So the negative is outside of that radical that has 4 underneath it. And so basically the idea here is what I'm doing is I'm pulling out the square root of -1 here. And that's something to look at because we'd like to say, well, gosh, we've got that negative underneath the radical, so how can I remove it? Well, I factor out, and basically you're doing a factoring out the square root of -1. What happens is I'm left with the 4 underneath the radical, and I have to keep the -1 underneath the radical, so I have the square root of 4, and then times the square root of -1. Okay, let's go back to our problem and finish it up. Okay, so we're going to, the third step here is we're going to simplify the radicals. And so again, we started out at this stage where we had simplified to 1 minus the square root of -4. We then moved to where we separated out the radicals. So we had 1 minus the square root of 4 times the square root of -1. And so now what we're going to do is we're going to take the square root of 4. That's going to give us 2. And then we're going to apply our definition of the imaginary unit. So the square root of -1 is I. And so we end up with the answer of 1 minus 2i. And so notice once again our answer is in that standard form of a plus bi. And again, we notice that I here is going to be equal to -2. All right, I know I have a plus there, but again, the b would be negative in this particular case. Okay, so that's the way we deal with writing complex numbers in the standard form, and how we've looked at two examples here, one where we have the square root of -1 underneath the radical, and the second example that we just looked at is the one where we had some other number underneath the radical that we needed to simplify and rewrite the complex number in the standard form. All right, so let's look at some problems where we have to deal with addition now of complex numbers. All right, so to this point we've looked at the definition of the imaginary unit. We've also looked at how to write complex numbers in standard forms with the definition of the standard form of a complex number. So now we want to see that we can take complex numbers and actually add two complex numbers together. So here we have the problem, we have 4 plus 3i in parentheses, plus in parentheses 7 plus 9i. All right, so we want to add these complex numbers together. Now, most of your standard textbooks that you have will have a definition of the addition. What I'm going to do here is I'm going to show you an example of how it works, and then your instructor for your particular class can direct you to those definitions in your textbook. But I want to show you the practical way of doing this, and I think then as you read in your textbook the formulas for this, they'll make a little more sense. Okay, so here we go. What we're going to do is we're going to do some grouping here, and we're going to group the real parts and we're going to group the imaginary parts. Okay, so we start off with 4 plus 3i in parentheses, plus in parentheses 7 plus 9i. So what I'm going to do is I'm going to first of all group the real parts. So I'm going to take the 4 plus the 7, and again I'm going to put those in parentheses here. So in parentheses I have 4 plus 7. So that's my real parts. The next thing I'm going to do is I'm going to group the imaginary parts. So that's going to be the 3i, and I'm going to group that with the 9i. And so in parentheses, I'm going to get plus 3i plus 9i. So as it stands right now, I have 4 plus 7 in parentheses plus 3i plus 9i in a separate parentheses. Okay, so we've pulled this together in almost towards the standard form, and that's really where we're headed for this, is the standard form of the complex number. All right, so next we're going to add and simplify. Okay, so we got to the stage where we put things together, and now we're going to add the 7 plus 4, that's going to give us 11, and we're going to have 3i plus 9i is going to give us 12i. So our answer comes out to be 11 plus 12i, and again, notice that answer of 11 plus 12i is in standard form. So what we did here is we started out with, in parentheses, 4 plus 3i, plus, in parentheses, 7 plus 9i. We grouped the real parts, and so that's adding the 4 plus the 7. Then we grouped the imaginary parts, so we added the 3i plus the 9i. And so when we did that, we end up with the real part of 11, the imaginary part of 12i, and putting those together, we had 11 plus 12i. Okay, so that's a basic example of how to do the additions of two complex numbers. Let's look at another example of complex number addition. Okay, so here I've got 5 plus 3i in parentheses, plus, in the second parentheses, -8 minus 9i. Okay, so notice in the second parentheses I have some negative values in there. I've got -8 and -9i. All right, so what we're going to do is we're going to repeat the process. And notice as I've gone along here, I've tried to give you processes that have 1, 2, or 3 steps in them, and you can follow those through as you're working your homework problems and solving different problems involved with complex numbers. Okay, so we start out with 5 plus 3i plus, then in the second parentheses, 8 minus 9i. And so again, we group the real parts together. So I take the 5 plus the minus 8. Okay, so notice since I'm adding here, I did 5 plus minus 8. Next, I'm going to take a look and say, let's group the imaginary parts. So I have 3i plus -9i. And so there we have 3i plus negative 9i. Now again, notice I left the negatives in there, I put the plus and minus in there. We'll take care of that in just a moment. All right, so as you know, as we're simplifying, we've gone through and now we've got the real part and the imaginary parts grouped together. And now we're going to do the addition. All right, so we have 5 plus negative 8 gives us our negative 3. We have over here, next in the next parenthesis, 3i plus a minus 9i, and 3 minus 9 is going to give us negative 6, and we'll have the I there. Notice that the i's don't cancel out. That's an important thing to keep in mind as you're doing here. The I doesn't disappear. This is very similar to what you would do in an algebraic expression. If I'm adding 3x and minus 9x, then I add 3 plus minus 9 to get minus 6, and the x would stay in there, so I'd still get 3x plus minus 9x would give me negative 6x. Same idea. Some students sometimes will say, well, can I look at this? The I is just another variable. In addition and subtraction, yes, you can. You can just deal with it just like you would any regular algebraic addition and subtraction as you'd have a variable. Now, as a little bit later on, we're going to talk about, in the next program, we'll talk about multiplication, and there's some differences that will come into play. But with addition and subtraction, yes, you can look at this just as a regular algebraic addition and subtraction with the i's being in there. Okay, let's now take a look at what happens with subtraction here. All right, and so we're going to take a look at this problem, 3 plus 3i minus 5 plus 9i. All right, and so notice there's a subtraction in between the parentheses. So in the first parentheses, we got 3 plus 3i, and then a minus in the next parentheses, 5 plus 9i. All right. So what we're going to do here is I'm going to approach this similar to how we approach an algebraic problem. We're going to distribute the negative through the second parentheses. And so what I'm going to do is, notice now I've changed the problem. And so I should actually put an equal sign in here. And so we're going to have an equals, and we're going to come down here and distribute the negative. So we distribute this negative to the 5, distribute the negative to the 9i. And so the sign here becomes plus. And so we have 3i plus 3 plus 3i in the first parentheses, plus in the second parentheses now we have negative 5 plus negative 9i. Okay, so again, I'm dealing with this as I would a distribution problem for any regular algebraic expressions. And so, we went a little bit too far there with that. So the next thing we're going to do is we're going to say, just like we've done before, we're going to group the real parts and we're going to group the imaginary parts. And so we're going to take the 3, and we're going to take the 5, okay? And again, the 5 was minus from what we had up above here. And so we have 3 and minus 5. Let me get rid of that overlay there. And then we'll have 3i minus 9i. Okay, so again, we had distributed the negative, and now we're going to add. And so again, we group the real parts and group the imaginary parts. And so we finish this up with our simplification as adding the 3 to the negative 5, or in a sense we're subtracting. So we have 3 minus 5, that gives us negative 2. And then over here in the imaginary part, we have 3i minus 9i, and again that's going to give us negative 6i. So we end up with our solution of negative 2 minus 6i. And so, again, that's in standard form. So we've written the answer in standard form like we will always do with the imaginary and complex number system. And so, keep that in mind as you're working through the problems. Notice that as I work through the last several examples, that we always put the answer for complex numbers in the standard form. Okay, well, this ends our program, and here we just want to review that we discussed the definition of the imaginary unit, where we had I was equal to the square root of negative 1. We define complex numbers to have a standard form of A plus BI. And then we examined the addition and subtraction of complex numbers, and we found that they were very similar to dealing with addition and subtraction of algebraic expressions. And so, but with the big difference is that we have to keep in mind that it is truly a complex number, that we have that imaginary unit I being equal to the square root of negative 1. Okay, this ends the first part of our discussions of complex numbers. In our next program, we're going to take a look at how to multiply and divide complex numbers.